Let's recall that an exponential function is a function whose form is f of x equals b raised to x. So dito, ang b natin should be an element of the set of real numbers. So dapat number siya. Okay? And should be greater than 0, but not equal to 1. The following graphs shows the generic behavior of an exponential function based on its base b. So the first graph shows ano nga ba yung graph kapag yung b natin is greater than 1. So you see na ganyan yung kanyang itsura. Ito namang pangalawa, ito naman yung itsura ng graph natin where b is greater than 0 but less than 1. So in the previous lessons, napag-aralan natin yung mga limit laws, and we know that it can only be applied whenever the limits of each component exist. And you also learned about the horizontal asymptotes of a function, that is, y is equal to L is a horizontal asymptote of f of x if either the limit of f of x as x approaches positive infinity is equal to L, or the limit of f of x as x approaches negative infinity is equal to L. Actually, yung mga limit theorems natin, pwede nating i-apply sa exponential function. For example, we are looking for the limit of 1/2 raised to x as x approaches negative 3. So in this case, pwede tayong mag-direct substitution. So that is 1/2 raised to negative 3. So that is equal to 1 over 1/2 raised to 3. Tama? Kasi kapag negative yung ating exponent, pupunta siya sa denominator. Okay? So we now have 1 over 1 cube over 2 cube, which is equal to 1 over 1/8. Ano nga ba ito? This is just equal to 8. Therefore, the limit of this function as x approaches negative 3 is equal to 8. Pwede rin natin gamitin yung limit theorems na yon dito sa pagkuha ng ganito. So we have the limit of 4 raised to 2x minus 2 times 4 raised to x plus 1 as x approaches 2. So pwede tayong mag-direct substitution. Okay, so that is 4 times 2. So pwede tayong mag-direct substitution. That is 4 raised to 2 times 2 minus 2 times 4 raised to 2 plus 1. So we have 4 raised to 4 minus 2 times 4 squared plus 1. So we have 225. Now, balikan natin itong dalawang graph na ito. So kung papansinin ninyo, it is evident that an exponential function of the form f of x equals b raised to x has a horizontal asymptote at y equals 0. Ibig sabihin nun, habang pa-increase ng pa-increase or pa-decrease ng pa-decrease yung ating x value, yung f of x naman natin palapit ng papalapit kay y equals 0. Theorem number 1 states that the limit of b raised to x as x approaches negative infinity is equal to 0 when b is greater than 1. While theorem number 2 states that the limit of b raised to x as x approaches positive infinity is equal to 0 when b is greater than 0 or less than 1. Itong dalawang theorems na ito can actually be observed pag tinignan natin yung graph ng b raised to x natin. Okay? So, pansinin ninyo na kapag ina-approach natin yung negative infinity when b is greater than 1, the limit is 0. On the other hand, kapag naman ina-approach natin yung positive infinity, yung b raised to x naman natin approaches 0 whenever b is greater than 0 but less than 1. Theorem number 3. It states that the limit of b raised to x as x approaches positive infinity is equal to positive infinity when b is greater than 1. And theorem number 4 states naman that the limit of b raised to x as x approaches negative infinity is equal to positive infinity when b is greater than 0 but less than 1. Theorem 3 and Theorem 4 is also evident in the graph. Makikita talaga natin dito na kapag ang b natin ay greater than 1 at ina-approach natin yung positive infinity, tama nga, papunta siya sa positive infinity. Tapos, kapag naman b natin is greater than 0 but less than 1, pansinin nyo naman, as we approach negative infinity, yung f of x naman natin papunta kay positive infinity.